Okay, this is the second video of the chapter 3, and we are going to define the mean as a measure of central location in this video. But before defining the mean, let me clarify the difference between different terminologies. Basically, they are the same thing. The average, the mean, the expectation, or the expected value. So there are three different names, but they are the same thing, at least in this course, right? Usually 99% they are interchangeable. Okay, so but the subtle nuance can be different, but like the average is a little more casual, informal, right? So just average is more like daily use, right? And the mean is the statistical term that as a like relative to like variance or the median. So it is more formal statistical term as a measure of data. And expectation is more mathematical because like say mean, there are different measures like mean, variance, standard deviations, and other things. But mathematically, we may say like this: mean is an expectation of a random variable. So and later you are going to learn that variance is a kind of expectation, a special form of expectation. So expectation is a mathematical operator to take a certain random variable and transform the random variable into a number. So that is exactly the same operator as the average, calculating the average and the mean, but it's a more mathematical term. Um, but but like anyhow, you don't need to at least in this course, you don't need to distinguish them. I am going to use them interchangeably, and literally I may read it like a mean of x or expectation of x. Does not make any difference, right? So, but notationally, we use expectation. So, because it's mathematical notation. So, expectation of x is literally the expectation of a random variable x. That is the mean. That is the average. Average of x, mean of x, expectation of x are the same thing. That's the first thing I'd like to clarify here. And then, before defining the mean, let's think about a probability distribution of a lottery. Like just simple example. Uh, say if you buy a lottery, there are two possible outcomes. With 1%, you may win $100, but the other 99%, you get nothing. So then, uh, there are only two possible outcomes, 0 or $100. So the expected price is $50, average of these two numbers. Is that right? Okay, obviously not. Obviously not, because 0 is much more likely to happen than $100. So cannot be the expected price must be much closer to 0, not exactly in between, in the middle of them, right? It is obvious. I told you, and I believe you agree with me. It is obviously wrong, but the problem is, if I make this question in the exam, like there is no exam here, but in this course, but I see a lot of students who say the answer is $50. I give these numbers and ask students to calculate the average, and they say $50. So that happens. So, all right, you understand. And as I said, it is wrong because the likelihood is not considered. A more likely outcome must receive higher weight, right? So then let me define the mean in this way. Then it will be more clear. The mean is the sum of probability weighted outcomes, right? So you have to put 99 times more weights on 0 than 100. Okay? So in general, this is how you define the mean. Say, imagine you have a probability distribution table like this. You list possible outcomes and their corresponding probabilities. Say x1 happens with probability of x1. x2 can happen with probability of x2. Da 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 da. There can be like a lot of outcomes. And then to calculate the mean of this distribution, of this random variable, you have to calculate this way. So you are going to multiply the probability to the outcome, to the corresponding outcome, because it is the weight. So weight. So outcome is weighted by the probability, and then sum all of them. So that is weighted average. And it makes sense because the sum of the probabilities must be always 100%, 1, right? So exactly the probability can be understood as a weight, right? More likely outcome receives more weight, and less likely outcome receives less weight, according to their probability. And then sum all of them, and using the summation notation, I'm going to write it this way. Multiply and then summation. Multiply, summation. That is how we define the mean. And as I said, it is easier when you say in a sentence, mean is the sum of probability weighted outcomes, right? So if probability is 0, like that outcome is not going to be considered because it does not happen, okay? So then now let's think about another example. Say GPA example. Like suppose that you'd like to calculate the GPA, right? You know it is a kind of average. So I assume that you received these grades from 10 courses last year, say. And to not offend you, I think it's generous, like good transcript, right? So you got A from one of the 10 courses last year, and 2 B pluses, and 4 B, and 3 B minuses, right? And by the way, if you write the outcome as A minus, B plus, B minus, then it is not a random variable because A minus are not numbers. However, we know how to describe them using numbers. We know how to encode them, how they are recognized as a number when you calculate the GPA, right? Okay, so then what you can see here is you have a number of courses where you get this specific grade. So out of 10 courses, 4 of them you got B, and only 1 course you got A. In that way, this becomes a frequency distribution table, right? For each outcome, you count the number of occurrence, right? Then let's calculate the average. First, what we are going to do is, I will follow the definition. So we are going to calculate the probability first, and then we are going to calculate probability weighted outcomes, and then we are going to calculate the sum of the probability weighted outcomes. That is the definition, okay? So first, convert the frequency into probability. Pretty simple. The total outcome, total number of observations is 10. So if it happened once, probability is 10%. Happened 0, then probability is 0. Happened 3 times, then probability is 0.3. So simply divide by the sample size, then you are going to get probability for the outcome. Probability for the outcome. That is step number 1. Step number 2. Now multiply the probability to the outcome, which is also straightforward, right? So you are calculating the probability weighted outcome. So 4.0 A, grade A, is likely to happen with 10%. So you receive that much as a weight. And 3.7, like A minus, never happened. So it does not receive any weight. And B plus, 20%, B flat 40%, B minus 30%. Okay, so multiply the numerical outcomes with the probabilities. Then the first outcome, like A, becomes 0.4 as a weighted outcome, probability weighted outcome. And A minus becomes 0 as a probability weighted outcome because it did not happen. In that way, you get numbers like weighted outcomes as many as the possible outcomes. So one outcome is transformed into a weighted outcome. Okay, so straightforward procedure. And then what we are going to do is we are going to add up these probability weighted outcomes. That is the definition of the mean, right? So calculate the mean by adding all these numbers. Then you will get 3.07. Good GPA. Are you satisfied? So this is the mean. This is the sum of probability weighted outcomes. Exactly, that's the definition of the mean, right? So this is the mean, and maybe what you may have thought is that this is different from what you have learned. The formula you learned maybe in I don't know, in high school or middle school. So I guess this is what you have in mind. This is, I would say, right, this is not wrong. This formula is of course not wrong, but I would say this formula is just a special case. This is a special case when you have raw data, but you don't have the true probability, right? So let me show you when this formula is used. For example, exactly same data I just showed you. I started from frequency distribution table, right? So this was the table we started from, but underlying data must be something like this, right? So it's raw data. Raw data is just list of numbers. It is not summarized. It is just processed data, original data, are just 10 numbers, 10 observations, okay? And then we processed this raw data into a frequency distribution table, right? So once you have frequency or probability distribution table, you can directly apply the definition of the mean. That is the formula you learned. Like so sum all the outcomes, all the observations, and divide by the sample size. That is maybe what you have learned. But we are going to get there from this data, raw data. Think of the raw data. And what I'm going to do here is I will approach to the data this way. So we have n number of observations, and still we keep our definition. The definition is the sum of probability weighted outcomes. The problem is we have outcomes, but we don't have probability. How can we handle that? We are going to assume that all the observations are equally likely. And then all the observations, there are n observations, each of n observations will receive the same weight. Of course, they are probabilities, so the sum should be 1. Then automatically, each observation receives probability 1 over n. That is how we interpret that formula. Okay? And think about that. There are n outcomes, and you are going to weight each of the outcome using probability 1 over n, under the assumption that each observation is equally likely, right? So, and then multiply probability weighted outcome, sum them, then easily you can factor out 1 over n. The same probability is multiplied to every outcome. So factor that out, and then this is what you get. Then in the end, what you can do is just sum the outcomes and then divide them by n. Then that's how you can obtain the formula, the simple formula. So the point is, definition does not change. The definition is that the mean is the sum of probability weighted outcomes. That is the key. Here is like actual application of the idea to our data. So you have 10 grades. From 10 courses, you got 10 final grades, and each of them receives probability 0.1, right? Then multiply, 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 to repeat that 10 times, and then sum the weighted outcome. Then you are going to get 3.07. Oh, this is again based on raw data. So what you learned is exactly what we are doing, but I'd like to extend your view to more underlying, more fundamental definition. And even further, I want you to view this as a measure of central location. What we are doing is we would like to summarize a lot of numbers into one number so that you can make an easy decision. Okay. So, okay, I think this is it. So summary, lastly, the mean is the sum of probability weighted outcomes, and you may use the true probability or calculate the probability from the data. So you need probability either somewhere, right? But here, then one more thing I want to briefly mention is that depending on the probability, your mean, the mean you are calculating can be different. So, and remember, the true probability is sometimes known like dice roll or coin flip. Then you know the true probability, so you can calculate the mean. Then the mean based on the true probability is the true mean. But however, when you flip a coin for a finite number of times, say you flip a coin 100 times, but you get heads for 51 times. That is possible, right? And then the probability based on the sample is 51%, which is not true. So the resulting mean will be also true. Will be also wrong. That is the random error, right? So then I'm going to distinguish them. The population mean is the true mean based on the true probability. Or mathematically, you may understand the population mean as the limit when you have infinite number of observations. So when you have, theoretically, if you have infinite number of observations, you know the truth. That is the population mean. We are going to denote this as Greek letter mu. However, it is usually not available. Population mean is not available because we cannot have infinite number of observations. Instead, what we can calculate in practice is the sample mean, which is calculated from the data. But the problem is, because the data is finite and the probability calculated from the data may have random errors, so as a result, the sample mean could be different from the true mean. So, and to distinguish them, we are going to denote the sample mean as x bar. Put bar on top of the letter, on top of the random variable. So then the statistical inference, it goes like this. We want to know the population mean, but we cannot calculate that. It is purely theoretical limit, but what we can calculate is the sample mean. So we are going to estimate the true mean using x bar, the sample mean, and then we will study the accuracy of that inference and like confidence interval, the margin of error, like confidence level. those things are basically based on the relationship between the population mean and the sample mean. That is the main theme, the say simple summary of statistical inference we are going to learn in chapter say 8, 9, 10, 11. Okay? Okay, thank you for watching. I'm going to stop here, and in the next video I will give you another example to study a little more complicated case. See you later.